Alright, the next function we're going to be looking at is the arc secant function, but before we look at it, we want to go back to the secant function itself. Would you agree that this represents a picture of the secant function?
Yeah.
Okay. Good. Once again, we are curious about reducing this size so we get this function being a one-to-one function. First question is it right now a one-to-one function? No. And our test is the kind of visual that doesn't pass the horizontal line test. No, it doesn't. It clearly hits up here more than once with the horizontal line. It also clearly hits down here more than once. So we need to pare it back, erase a little bit, to get back to a location where it's going to be just one-to-one. So what parts might we want to eliminate from this picture?
The two halves.
Okay. So that part can probably disappear, and so can that part without a lot of difficulty. Probably not a lot of disagreement there. What else might need to disappear to help us get to one-to-one?
The two bottom ones.
The two bottom ones. One of the bottom ones.
Two.
Okay, now wait a minute. When you say two, you want both of these to go away? Is that what you're telling me?
No.
No.
No, I don't want both of them to go away. I've got to keep part of one of them.
One and a half. Or one and a half.
Yeah, one and a half of them go away. The question is which parts are the one and a half. Can we get rid of this one on the negative side?
Yeah. Yes.
Okay, let's do that. We'll get rid of all this negative stuff. For those of you who don't like negatives, there we go. It's gone.
And then you can erase
And take the,
the
could
first
you keep
half.
the negative side of that one?
I can take the negative side of that one away too.
And then you could take
Then you take the positive, the larger side of the.
So the right-hand side of this one would go away. So where am I now working between?
Does it matter if you take
I and zero.
does it matter if you take the left or the right side on the
It does for both of these. Guys, remember when we did the arc cosine function, we stuck between 0 and pi. This is the reciprocal of the arc cosine function. So because it's the reciprocal, we're still going to be working between 0 and pi. The difference is we have this asymptote in between. We have to account for it as well. Domain is therefore going to be bracket 0, comma, pi over 2, parenthesis, union with parenthesis, pi over 2, comma, pi, brackets.
I don't have
Wait, what's that little thing in the middle?
That's a U for union.
What?
It allows me to put the two different intervals that are separate together as one big grouping. That's what union allows us to do. Yes, ma'am? Okay. But you'll notice that the brackets show up on the ends because we can equal 0 and we can equal pi. But the parentheses show up in the middle because we do not want to equal pi over 2. That is where it's undefined. Okay. Next one.
Okay.
Would you agree that that describes from here to here
Yeah.
with a break in between? That's all I'm trying to do.
That just looks super confusing. So.
Well, as I'm preparing you for calculus, we do that stuff all the time in calculus.
Oh, awesome.
So we got to get used to it.
I'll just sign up for that, right?
Good, I'm glad to hear it.
Oh.
Wouldn't it be one to infinity?
This part is 1 to positive infinity. What about this part down here?
Negative 1 to negative
Well, let's do it in proper interval notation. Say negative infinity to negative 1. Remember, we're always going to increase there. And then union, we do skip, then from 1 to positive infinity. So, yes, that's what it needs to look like. Remember, go small to big with intervals. Small to big. And we can equal the negative 1 and positive 1, but we're not going to equal the infinities because they're just approached. Questions about that? Now we're going to take a look at the arc secant.
Yeah, can you go back up to the range really quick?
And we know what happens with domains and ranges. Yeah, the domains and ranges just switch. So the domain of the arc secant function is the range of the secant function. So this becomes then negative infinity comma,
Thank you.
to negative 1, union with 1 to positive infinity. That would be my domain.
Okay.
And then range?
Zero to pi over 2.
Union with? Right?
Yeah.
Okay. So there they are. Now let's graph it. And I'm going to think about my range. I've got an asymptote that goes in here at pi over 2. So that is going to be about right here. And then I've got a value that's going to come up here to pi. That's my y numbers. My x's span this way, but I have a spot that is here at positive 1, and I have something going on at negative 1. Remembering that our ordered pairs switch when they mirror across that line y equals x, I have an ordered pair right here that is 0, 1. So that's going to come down here and be 1, 0 right here. Oh yeah, I need to put the asymptote in there. And so this curve is going to go up and approach this way. I also have this point here, which is at pi, negative 1. And when I take its reciprocal, or its inverse, it becomes negative 1, pi, and it's going to go this way. So there is your arc secant graph. Questions about that?